Hello and welcome to Chemistry with Dave Hicks. Today we're going to talk about gas laws and mostly focusing on Boyle's and Charles' law. Another thing about this presentation is that I'm setting it up for the International Baccalaureate program. And so some of the units will be a little bit different maybe than what you might be used to in a traditional chemistry class. So our goals here today is first we want to know the formulas and the units associated with the gas laws that we're going to be using today. You should be understanding some of the relationships between these variables in the gas laws. And finally, of course, we want to calculate some answers to some gas law problems. If you're looking for background information on Boyle's and Charles' law, the theory behind it, what we would call the kinetic molecular theory, I'd suggest you do a little reading or maybe watch another video of somebody who's going to explain that kind of stuff. Here, I'm just going to be focused on how to do these problems and help you on your way with your homework. And hopefully that's what you will feel better doing. So, we're working with Boyle's and Charles' law. Here's the definitions of the two. Now, Boyle's law says that the pressure and volume are inversely proportional. And I like to tell my students that that's kind of like what I call a teeter-totter program. So the teeter-totter is like this. And pressure's on one side and volume's on the other. And so if, pressure goes up, the volume has to go down, right? So, and vice versa. So that's what I mean by a teeter-totter problem, meaning when one's going up, the other one's going down. It's not a traditional setup for something that you would consider proportional. In fact, the formula for this is P1 V1 is equal to P2 V2. So we can see that these two things are equal to each other. It's the same gas, but if I change the pressure and volume, the system has to remain equal to some what we call constant. So P times V has to remain a constant, and they have to be equal to each other. So what we're saying here is that if we make pressure really big, then that means that our volume is going to have to decrease and become very small, right? Or likewise, if my volume is really big, then my pressure has to decrease and become really small in order for those to remain equal to each other, right? So Boyle's law is inversely proportional, which means that we multiply them. One goes up, the other goes down. Charles' law, I say to my students that this is like an elevator problem. And on an elevator, if I have temperature and volume on an elevator, they would have to go up and down together, wouldn't they? So this is your typical kind of directly proportional kind of problem that you're used to. The formula for this is V1 over T1 is equal to V2 over T2. And with this one, you can see that the difference or the division of volume and temperature has to remain a constant. So if V over T, right, has to remain a constant, then if you have a really big volume, in order to stay a constant, you would also need a really big temperature, right? Equally proportional change in temperature in order to remain constant. Likewise, if something gets really small, then both of them are going to have to be small in order to end up with a constant all the time, right? So we're taking a look. Here's the formulas that we need to know right here. And here is the relationship. One goes up, the other goes down for Boyle's, and they both go up and down the same for Charles. Let's talk about units for just a minute. So we're going to use units to be the Pascal or the kilopascal. Standard is 100 kilopascals. So when we talk about standard temperature and pressure, the standard pressure is 100 kilopascals. The Pascal is kind of a physicsy unit, I'm going to say. I'm not going to dig into too much of what it is. I just suggest that the way to handle that is, recognize what the unit is and recognize that it's going to be used like metrics. Yeah, kilopascal. So we know that like 1 kilopascal is going to be equal to 1,000 pascals. There we go. And so, you might have to make conversions between these two things, and just be prepared for that. And when you see the unit Pascal, just work with it. It's in pascals. That's a unit of pressure. So volume, we're kind of used to working in liters in the chemistry classroom, but the actual SI unit for volume, it would be some derivative of cubic meter, okay, because meter is the SI unit of length, and a volume is length times width times height. So that's where we're getting cubic meters from. So it could be a cubic decimeter, and that would be this one here. And in that case, that would be equal to a liter. That's what you would more formally know it as. And then, or less formally, I should say, and then cubic centimeters, which is the same as a milliliter. If I created an equality with this, then I would say that 1 cubic meter, 1 cubic meter is equal to 1,000 decimeters cubed. And we know that 1,000 decimeters cubed would be equal to 1,000,000 cubic centimeters. So if you had to convert between those, there's a conversion that you would be able to use for that, maybe. Finally, temperature. The SI unit for temperature is in Kelvin, and I can't stress this word enough. For these problems, it must be in Kelvin. These gas laws are based on the kinetic molecular theory, and the kinetic molecular theory says that temperature is the average kinetic energy of the particles. And kinetic energy of the particles we're measuring in the unit of Kelvin. Most of your temperatures, like Celsius or Fahrenheit, they would have degrees, right? So that means they're relative to something. This is an absolute. Kelvin is based upon an absolute. And some of you might know that that absolute is absolute zero. Okay, so if you want to get between Kelvin and Celsius, which this people have to do a lot for these types of problems, then we know that Kelvin is going to be equal to degrees C plus 273, and that will get us into Kelvin. So there is our conversions that we can use if we need them. Final note on the bottom, we're going to notice that pressure and volume units many times are going to cancel out. So we can use any unit that we want to. But the temperature must always be in Kelvin in order for this to work. All right. So let's try some of the maths. So for Boyle's law, it says I've got myself a bubble. It's going to start underwater and it's going to expand as it comes up to the surface. And if the pressure is going to start out at 350 kilopascals, and when it gets to the top, it's going to be 100 kilopascals. So what's the new volume? And we're assuming that temperature is constant here. So we don't have anything that we have to change at all for this. But So basically all I have to do is just set up the problem, right? We know that the problem goes P1 times V1 is equal to P2 times V2. Want to make sure things get together that start together, right? So we have 150 cubic centimeters that's starting at 350 kilopascals. So those two things are going to have to go together. So I'm going to start out with my 350 kilopascals and multiply that by my 150 cubic centimeters. Now, I don't have to do anything with these units, see, because they're just going to cancel out. The pressures here are on both sides of the equation, as are the volumes are on the both sides of the equation. So you know when things are on opposite sides of an equation, they cancel out. So we don't have to worry about what the units are and whether or not they are exactly in the SI unit itself. So no worries with Boyle's law. So on the other side, we see that the pressure at the surface there was 100 kilopascals. And I'm going to assume that that has 2 sig figs in it there. That way it matches all my others. And I want to know what is the new volume going to be. So multiply this one and divide it however you like, whichever way you're comfortable doing this. When I did it on my calculator, I got 525 cubic centimeters. So once you recognize that it's a Boyle's law problem, which I guess I didn't go over, how do you know if it's a Boyle's law problem? Well, the first thing you do is you're going to take a look at your units. That's why we studied those first. And I see I have a unit of volume here, and I have a unit of pressure there. So this is volume and pressure. And you should just know that this is Boyle's law. If you haven't memorized that yet, that'd be something that you would commit to memory. Pressure or volume, Boyle's law, PV equals PV. All right, doing good. Let's get to Charles' law here. So for Charles' law, I've got a balloon. It's going to start out in an air-conditioned store. We're going to put it inside a car in the hot summer sun. So our temperature is going to go up, and we want to know what's the new volume of the balloon, and we'll assume that the elastomer of the balloon is going to keep it at a constant pressure. All right, so the first thing we have to do is consider our units. How do we know this is Charles' law? Again, I'm looking at it and I see a unit of volume and I see a unit of temperature here. So I know temperature, volume, that's Charles' law. The first thing I need to take care of, though, is that temperature, because the temperature must be in Kelvin, right? So I'm going to convert my two temperatures right away here. I'll start with the 22 degrees C. I'll add 273 to it. And when I do that, I get 295 K. And likewise, I'm going to take the 85 degrees C and add 273 to that. And I end up with 358 K. Okay. So now I've taken care of that. Convert those temperature units. These are pluses here. There we go. And next thing to do is just to set up the law. And so to set up the law, T over V is equal to T over V. Or I guess I have it the other way here. I'm going to say V over T is equal to V over T. How's that? You could have done it the other way too, but this way is going to work out a little nicer for us. And so the first one, we said the volume was 1.5 decimeters cubed. And that's at a temperature of 295. And so what's the new volume if my temperature rises up to 358 Kelvin? Okay. So again, however you solve this one algebraically, cross multiply, divide, whichever way you are most comfortable with. I ended up with 1.8 decimeters cubed. Again, don't be scared of these units, decimeters cubed. Just work with them. Let them flow, and you'll get used to the unit itself, and it will just become a thing, right? And as you get experience in the laboratory or other places like that, you'll be more comfortable calling something a decimeter cubed and having a picture in your mind as to what it really is. Okay, so I've done a couple here, and what I'd like you to do is I would like you to try a couple on your own, okay? So here we go. The great thing about video is that you can hit that pause button, work these problems out, and when you're ready, click the start button again, and I will go ahead and do the answers while you are working on yours. All right, so hit the pause button and then come right back for an explanation. All right, you back? How'd you do? I bet you did great. Did you recognize that this first one is a Charles law problem? Look, I've got a volume and I've got a temperature, right? So you know I had to convert those temperatures into Kelvin first, right? So that one and minus 12, sure, no problem, right? And you're saying, God, I'm not good with negatives. That's okay. Use your calculator. It'll do it for you. I used mine, and I got 261. There we go. Interesting note, Kelvin doesn't have any negatives, right? Because 0 is as low as it can go for the Kelvin. It's absolute. That's what we were saying. So again, we'll set up our problem here, and our problem is V over T equals V over T. So I'm going to have my 25 cubic centimeters divided by the 298, and that's equal to what volume at 261. And when I did that, it came out to, get my units here, 22 cubic centimeters. Did you get that one okay? Finally, the last one over here, I've got 230, whoop, I'm giving the answer away. I've got a Boyle's law problem. How can I tell? I've got a volume, I've got a pressure. Pressure and volume is Boyle's law. Remember, we don't have to convert anything with this. We can work in whatever unit we want to because they cancel out. So I just need to sit down and go PV equals PV. So that would be 99 kilopascals times my 0.35 meters cubed. And that's equal to what pressure? I'm looking for a pressure, huh? If it gets compressed to 0.15 meters cubed. Okay, and again, do your math however you want to do your math for that, and solve for P. And when I did it, I came up with 231 kilopascals. Ooh, probably 2 sig figs, right? Just 230 would be a better answer. Okay, so I hope we have learned a little bit or feeling a little more comfortable with these two gas laws. Hey, join me for other gas laws and other chemistry tutorials at my YouTube channel. I appreciate it. Have a good day and have fun with your chemistry.